Welcome back. So let's now understand what is bagging or bootstrap aggregation. In the last lesson we understood what we mean exactly by bootstrapping, but we don't really care about bootstrapping by itself, but we want to apply it in machine learning, right? So what is bagging? The basic idea of bagging is to create different models, different machine learning models, using different bootstrapped training sets and take the average of their prediction to produce the final output of the model. So we will create B samples, right? We will create B datasets, and we do this sampling using the bootstrapping. So we resample with replacement. Okay? So why this is actually good? It's good because it will reduce the variance of the model. So how it will reduce the variance of the model? It will reduce the variance of the model because there is replacement. So some examples are repeated in the first model and in the second model and in the third model and so on. So the variance of the model will decrease. And so the overfitting chance will also decrease. So as we know, variance and overfitting are correlated. So if we have high variance in the model, then this means the chance of overfitting is higher. And the opposite is true. So if we have a low variance for this model, then the chance of overfitting is also low. And bagging also is important because it can reduce the chance of outliers. So we can have outliers in our dataset, right? Outliers are basically examples that are not from the same distribution of the data, right? So if the distribution of the data is something like this, then the outlier might be something like this, right? Some data point here. So it's clear that this is an outlier, okay? And we know all about outliers from the statistics section. Now, outliers are likely to be omitted in case we use bagging. Why? Because the chance of having outliers in our bootstrapped samples is very, very low. Because here we can have 100 examples, and out of these 100 examples we have 2 outliers, for example, okay? So the chance of these 2 outliers appearing in many samples or in many bootstrapped samples is very, very low, okay? And when we take the average, then their influence, the outliers' influence, is very, very, very small. So that's why bagging is very, very robust against outliers, okay? Now, this is also a visualization of what happens. So we have the training sample, okay? So this is our training dataset. We will create bootstrapped samples using the bootstrapping technique. So we create the first training dataset, the same size of the training sample, but with replacement. And the same here. So we can have n samples, okay? N bootstrapped samples. The first dataset will be the input for the first classifier or the first regressor. And the second bootstrapped sample will be the input for the second classifier or regressor, and so on. And then we combine all these classifiers, all these weak classifiers, in one strong classifier called the ensemble classifier. And then for classifying the test data or predicting the test data, we use the ensemble classifier. We don't really use any of the classifiers alone. Okay, so the algorithm steps are very, very simple. First, we generate B different bootstrap training datasets using the bootstrapping technique, and then we train our machine learning method on the B bootstrapped training set. And if you notice here, we didn't really specify if this is a KNN, if it's a decision tree, if it's a logistic regression. We didn't really specify here, right? Because this is a concept. The bagging is a concept that you can use with any machine learning model. Of course, there are some machine learning models that fit this criteria better than the other ones, but it's a very generic approach. So we will train our machine learning models using these bootstrapped samples, and then in order to make predictions, we will take the average of each model, right? So for each model, we will come up with a prediction, and we will sum these predictions together and divide by the number of predictors. So basically we are taking the average, right? So this is the bagging steps. Now, how we calculate the test error in bagging? This is a very, very important topic, and it can be a little bit tricky to understand. But in the next lesson, we will see what do we mean exactly by out of bag error and why it's important, and understand how we can calculate it and everything about out-of-bag error. And by this, we will have a clear idea about bagging, so we can apply it in the lesson after that in the random forests, one of the bagging application or the bagging algorithms, right? So let's go to the next lesson.